Hey guys, good day everybody. So today we have a nice short video and we're going to talk about bearings. Now for bearings we are going to need some of our knowledge in trigonometry. Bearings is a topic that could use anything from trigonometry. So we'll need to know our rules for angles like alternate angles and all of these kind of things. We'll probably need to remember our SOHCAHTOA and maybe even the sine and cosine rules, right? So bearings is a topic that could use all of these trigonometric ideas. However, once we know all of these things that we would have done previously, it's pretty simple of a topic. The main thing that we need to know with bearings are directions, and we could see here just a little reminder of our directions. So, right? Now what a bearing is a bearing is the position of an object relative to another object. This is called a bearing, right? It's the position of something relative to something else, right? So when we talk about position now, we're basically talking about degrees, we're talking about direction. So I could have a port over here at the center, and I could have a ship that is northeast in a northeasterly direction from the port. And I could have another ship that is in a southwesterly direction from the port. Yeah. So with bearings, we're talking about the direction, the distance, as well as the angle. Now there's one important thing that we need to know about bearings, right? One important thing we need to know about bearings is that the angle is always measured in a clockwise direction from the north line. So from this north line in a clockwise direction is where we would be measuring from, right? So if I had a ship over here, right, let's call it the ship S, right? Then that ship from the port P in the center, right, would be from the north line. I would measure my angle in a clockwise direction, 45 degrees. So that ship is from the port, it is 45 on a bearing of 45 degrees to the northeast, right? Similarly, if I had an airplane over here and the airplane is at a certain distance from the same port, right, we have to measure that distance from the north line all the way around in a clockwise direction, 225 degrees. So this airplane over here, A, is on a bearing of 225 degrees to the southwest of the port, right? So we just remember that when it comes to the bearing of an object is the angle measured in a clockwise direction from the north line, right? North of the object. So if this is north here, right, we will be measuring from this north line in this clockwise direction, and we can see here that we have the 45 degrees, the 90 degrees, the 135. Down here will be 180 degrees, of course, 225, 270, 315, and back to 360, back to 0 degrees north. Yeah. So whatever angle that we measure in, please remember that we are measuring from the north line. Another thing to remember is that, and you'll notice here 0, 0, 0, 0, 4, 5, 0, 9, 0. I'm always using 3 digits for my whole number, right? So if I have a whole number, when I'm referring to the angles, of course, for bearings, I will always use a bearing of 045 degrees. I'll always use a bearing of 090 degrees. So with bearings, we often use 3 digits in our whole number. Of course, we could still have as many decimals as we want. Once the whole number, when we're talking about the angles here, we use 3 digits, right? Now let's get to some bearings questions, and the questions are really easy. Now you'll see what I'm talking about here when it comes to the knowledge, previous knowledge of trigonometry coming into play, right? By drawing a diagram, as the question says, by drawing a diagram, determine the distance traveled north and the distance traveled east by a plane flying on a bearing of 50 degrees for 100 kilometers. So I have a plane and it's flying from somewhere to somewhere. So it's flying from here, and this is the north line, right? So I'll put wherever the plane is coming from, and I'll just sketch a north line, north. And from the north line, we say that the plane is flying on a bearing of 50 degrees. So from the north line, I will measure about 50 degrees to be about that. And this is the line that the plane is flying, and it will fly that line for 100 kilometers, right? So the question is asking, find the distance traveled north and the distance traveled east. Well, we could see here the distance traveled north means this north line here, and the distance traveled east would be this line here, right? So obviously we could see some trigonometry coming into play. We have ourselves a right angle triangle with the north and the east direction. We have the actual bearing that the plane is on that forms the hypotenuse for this. So this will be the hypotenuse here, right? This here will be my adjacent next to the angle that we have, and this here will be opposite to the angle that we have, right? So now that I have all of this, I actually want to find this adjacent side, and I want to find this opposite side. So the adjacent side is the distance north, and the opposite side will be my distance east. So obviously we could use SOHCAHTOA, right, which we would have previously learned in trigonometry, sine, cosine, and tan, right? So how do we do this SOHCAHTOA? Well, we look at what we want. We want the direction north. We have the angle, we have the hypotenuse, we want the adjacent. So we could see here that we have the hypotenuse, we want the adjacent, so we will use cosine, right? So the sides that we have are adjacent and hypotenuse. So cosine deals with adjacent and hypotenuse. The cosine of 50 degrees will be adjacent, which is the north direction, over the hypotenuse of 100. Therefore, my north direction will be 100 multiplied by the cosine of 50 degrees. And my north direction will be approximately 64 kilometers. So we found that the north direction will be about 64 kilometers, and let's find the easterly direction. Well, the east is the opposite side of the triangle here, so we're dealing with opposite and hypotenuse, so that is sine, opposite, and hypotenuse over there. So the sine of 50 degrees is opposite over hypotenuse, so that is E, the distance E over the hypotenuse 100. Therefore, my distance east will be 100 multiplied by the sine of 50 degrees, and the distance east will work out to be approximately 77 kilometers to the nearest whole number. So we could see here that for this question, we needed to remember that once we see the word bearings, that means the degree measured from the north line. So we must always draw our north line and use our angle from there. We could also see that this question required previous knowledge of SOHCAHTOA, that is sine, cosine, and tangent. Now let's take a look at this question here. Right, so determine the bearing on which a car drives from a park if it finishes 30 kilometers east and 75 kilometers south. So the car is coming from the park, right? So let me just draw my park here. This is my park P, and I'll make sure that I have my north line. This is north. And it says that it finishes 30 kilometers to the east. So I'll average 30 kilometers to the east. And then I will average 75 kilometers south. Now this is where my car ends up. Now we could see here it kind of reminds us of vectors in a way. So the car, the resultant would have been this line here. That is the line that the car traveled, right? 30 kilometers east, 75 kilometers north. Determine the bearing. Once we see the word bearing, we are talking about the angle from the north line. So from this north line, I want this angle here. So how am I going to find that angle there? Well, we can see I have a right angle triangle, but let's draw over the right angle triangle. Let's put our south line, because the car goes south, over here at 75 kilometers, and then the car goes east over here at 30 kilometers. And we have the right angle triangle there. Now it might be a little easier, because we could use SOHCAHTOA and find this angle over here. And seeing that this north-south line is a straight line means that we could use the rule of angles on a straight line are equal to 180 degrees to find our bearing. So let's do that. We want to find this angle theta over here. And we can see that we have adjacent and opposite. So again, SOHCAHTOA, we're talking about tan this time. Tan theta is equal to opposite over adjacent, right? So the opposite in this case is 30 over the adjacent, which is 75. Therefore, theta is going to be the tan inverse of 30 over 75, and theta is going to be approximately 22 degrees. So if this is 22 degrees and a straight line is 180 degrees, then our bearing B, let's call the bearing B. So the bearing will be 180 degrees minus the 22 degrees, because angles on a straight line. It's always good to write the reason, to write the rule that you're using here. So 180 minus 22, that gives us about 158 degrees. So therefore this car from the park drove at a bearing of 158 degrees. Now let's handle one a little bit more advanced, and we have here a CSEC past paper question. Now we just need to know our our basic bearing rules that we are always measuring the angle from the north. And we just read the question and understand it carefully. Yeah, so let's check this out. A ship leaves port A, so we can see this is port A, and it sails 52 kilometers on a bearing of 44 degrees to port B. This is port B over here, right? So it's telling us that from port A to port B, the bearing, which is this angle here from the north line, is 44 degrees. Yeah, and it also tells us that the distance from A to B is 52 kilometers. Nice. The ship then changes course to sail to port C. So from port B, it changes course and it goes to port C, which is 72 kilometers away. So we see here that 72 kilometers, right, on a bearing of 105 degrees. Remember, bearings are always measured from the north, right? So it's this angle here from the north line. On the diagram below, not drawn to scale, label the known distances traveled and the known angles. Well, we already did that, so that's 2 marks for us. Now we have to determine the angle ABC. So if we look at it, the angle ABC, that is actually this angle over here. So how can we determine that angle? Well, if we look at it, we could see that I have 2 north lines at A and at B. So if I was to draw over my 2 north lines, this is the north line at A, and I have another north line here at B. Because these 2 lines are true north means that we could take them to be parallel. So now we have the rules for angles coming into play. Because we saw here that the bearing from A, from the port A, was 44 degrees, right? And what we have here is we need to know this angle over here. This angle is a co-interior angle. So we know that that angle, co-interior angles, always add up to 180 degrees. So therefore this angle here would be 180 degrees minus 44 degrees, which would give us 136 degrees. So that what we just found there was this angle here, 136 degrees. So now we want the inside angle, the angle ABC. Well, we could see that these are angles on a point. So angles on a point equal 360 degrees, right? So therefore, we could find the angle ABC, the angle ABC, if we take 360 degrees and minus it from these 2 angles here, the 136 plus 105, yeah? So 136 plus 105 gives us 241, and 360 minus 241 gives us 119 degrees. So therefore, the angle ABC over here is 119 degrees. So we could see here that for these questions, we had to recall some of our rules for angles. We had to recognize that these north lines are parallel, yeah, as well as remember angles around a point and angles on a straight line. Now let's check out part 2. Calculate to the nearest kilometer the distance AC. So AC is this distance here. AC, let's call this the side A. So I want to calculate this distance over here. Well, I could see that obviously I'm dealing with a triangle. And because it's not a right angle triangle, the only tools that I have right now are my sine and cosine rules. So maybe one of them might help. Well, with the sine rule, I know the sine rule is A over sine A equals B over sine B. You can see that I need two angles. So it wouldn't be the sine rule. I don't have two angles. All I have is this 119 degrees inside of the triangle. So chances are I'll use the cosine rule because I want to find this side opposite the angle. So if this is the side A, then the angle opposite would be the angle A. So therefore the cosine rule is A squared, the side A, is equal to the other two sides, B squared plus C squared, minus 2 times B times C, the cos of the angle A, which is opposite to the side A. And thankfully, we have everything that we need. We have the two sides. We have the angle opposite to the side that we need. So the cosine rule is the perfect fit. So now I could say that A squared will be equal to B squared, which is, any one of these I could take as B or C. So B squared, let's take it as 52 squared plus C squared, which will be 72 squared, minus 2 times 52 times 72, multiplied by the cos of 119 degrees. So therefore A squared now will be equal to this huge number, 11,518.25. Therefore A will be the square root of that, approximately 107.3 kilometers. So this side here gives us 107.3 kilometers, and we got that using the cosine rule. Now, the last part, show that the bearing of A from C to the nearest degree is 260 degrees. So show that the bearing of A from C. So from C, I am going towards A. So I want the bearing from C. And remember, bearings are always measured in a clockwise direction from the north line. So that means I want this angle here. Now that angle there, clockwise direction from the north line, that is the bearing of A from C to the nearest degree is 260 degrees. So I have to show that this angle is about 260 degrees to the nearest degree. So how can I do that? Well, I have a couple of ways. We could see here that I have two north lines here and here, which are parallel. So that means that I could find this co-interior angle here, which will be the 180 minus that 105, that means that this here is about 75 degrees. So maybe I could find the angle inside of here and then use the angle around a point to show that this is 260. So what the angle inside of here could be, right? Well, we see that we have this angle and we have the opposite side. We have this angle and we have the opposite side. So maybe we could use the sine rule, right, to find what this angle here is. This is the angle that we want. So this is the angle we want, angle B, and this is side B. And we already know that this is side A, and this is the angle A. So I could find, using the side rule, the sine, or the angle B. So the sine rule is A over sine A equals B over the sine of B. So since it's the angle B that I want, let me just make it the subject of the formula one time. So therefore the sine of B is going to equal to B multiplied by the sine of A, all divided by the side A. So now let's put in our values. The sine of B is equal to the side B, which is 52, multiplied by the sine of the angle A, which is 119 degrees, divided by the side A, which is 107.3 kilometers. So now that we have that information, let's check it out in our calculators here. So from our calculators, this works out to be approximately 0.424. And therefore, B will be the sine inverse of this, approximately 25 degrees to the nearest degree. So, if we have this that we've shown to be 75 degrees, and then this that we've shown to be 25 degrees, then this angle here will be 75 plus 25, which will be 100 degrees. So since this angle here is 100 degrees, that could only mean that because the angles around this point is 360, that this bearing will be 260. So hence, angles around a point implies that I have 360 degrees, right, which is the total amount around that point, and I'm going to minus the 75 degrees and the 25 degrees that we found, one being the co-interior angle and the other being from the sine rule. So from this, I could actually see that the bearing B is actually about 260 degrees, which is what they asked us to prove. So this concludes our class on bearings. It's short. It's a nice, easy topic. The only two things you have to remember is that you are measuring your angles from the north line and that you are always measuring in a clockwise direction if you are talking about the bearing. Once you're talking about the bearing, you're talking about a clockwise direction from the angle north. So I hope that this was helpful, and yeah, I'll see you all in the next class.